Okay, so first, a round of applause for this group, fantastic group of people. All right, so questions, ideas, comments? Okay, that was easy.
If you don't start asking us questions, we'll start asking you.
First of all, thank you for the great presentations today. My question is, what would you say to someone who's kind of standing on the lines and deciding what networking effort to join, whether NSM or DANAM or Malthus, or why should someone join your effort?
Is it on?
It's on.
Yeah, okay. I mean, we get this a lot, like when we show NSM and people start, okay, but there's Motus already. Why would I want to use that? And I think that the answer is pretty simple, at least for me. It's because of the cloud nativeness of the project. We are very much, as I tried to say in the morning, we are very much aligning our goals and our principles that we are trying to build in NSM around this definition of from the TLC, from CNCF TLC. And we're also participating in CNCF's telecom user group. And during the discussions there, all the interactions that we have with various people, at least for me, I find very, very much that NSM is much applicable, and I think that today it was kind of proven. I was not aware of at least half of the things that were happening here. I was really surprised by what's going on around NSM. I mean, I'm one of the contributors there, so I was hoping to at least have an idea what's going on. So, to me, what happened today kind of verified that we are on the right path. There were a lot of statements saying, okay, we believe that NSM, okay, we're not yet the established solution, but I think that we are on the right path. Does that answer somehow the question?
So,
Well, I have an answer.
Okay.
I think that it's also about the community that you see ahead of you, in front of you, and around you. I wasn't really aware of the community here, but it's such a diverse group of people in terms of like their backgrounds and stuff like that, and they're all working towards the same goal, and they're working in a variety of different ways in terms of applying it. So having this really strong community behind it that's going to continue growing it going forward, whether it's through enterprise or super network-oriented people, or all the various backgrounds, I think that's super powerful, and it's going to continue it going forward.
So I have some more to add to that in terms of a historic side. So I had the opportunity to work with a person who used to be at Intel named Ivan Coughlin. Ivan was heavily responsible for the creation of Multis, and we used to hop onto a call every week, and we'd have conversations about problems that we had in Kubernetes. One of them was the lack of multiple interfaces that many of the telecoms and other groups were starting to ask for. And Multis was a result of some of those conversations. And one of the things that Ed and I realized is it's not just about the connection. So, like, Multis is an important project in that NSM would not exist without it for a start. Like, we learned a tremendous amount from Multis. The other thing is that NSM is not competing directly with Multis as well. That's a misconception that a lot of people have, is that, it's about getting multiple interfaces into it. Well, for Multis' purpose is to get multiple interfaces to have multiple CNIs. It is a CNI multiplexer. NSM is about, what happens after that? Like, how do you configure and control in a declarative way where you bring your configuration from out of band to in band? I actually see Multis as a potential possibility to work with or coordinate towards that, where perhaps you could need a pod that needs spun up with some set of parameters. We could configure something that Multis could then consume that would then land that into that space. And so Right now, there's not an integration for Multis, but they're not really competing with each other. They're like we had to add something in for injecting a second interface or injecting in the shared memory interfaces specifically, because there was no answer for that, which is part of the reason why we added in those various activators. But at the end of the day, like for us, that's an implementation detail. It's not our main goal. And so, yeah, I personally would love to see people with Multis come and join and try to work out, okay, well, how can we integrate in and do some interesting stuff?
I think that NSM is so much more than like a CNI. A CNI is lifting an interface from the host space into the container. It doesn't tell you what the IP addresses to give to it or anything. You can try to put it in the CRD. The thing people most often get is that they get the collision of IP addresses because it's not made for this, I mean, really. So there I see NSM. I like the decoupling of the hardware from the logical network. So I can have a cable. I could, in a big deployment, say that those 4 machines have all the cables coming in, and then I have the internal backplane, and then the NSM will set up the rest, I think.
Okay, so one question, 4 answers. Okay, another question here.
I'll just add on to that. We saw presentations talking about marrying SDN controller with NSM. In a way, what you were describing looked like some of the things SDN controller would do. So how would you see that integration going forward? One of your presentation,
Yeah, that was ours. We kind of, what we did was we sort of took what the networking industry has described as a SDN controller, and we said, let's sort of deconstruct that thing and get it down to, really when it comes down to it, it's about use cases, like what a given application is trying to do or a given end user is trying to do, and expose that capability to that user and abstract the whole controller thing altogether, or just kind of treat the controller as a distributed database, essentially. So controller isn't even it's not even in our presentation per se. It's just a bunch of services that you can access.
Okay. Thank you.
I don't know how helpful that is. It's, in a way, we kind of, you look at a given sort of network problem that you might have to solve, and this is ultimately kind of going back to the previous question as well. There's 1,000 different or 10,000 or 100,000 different complex networking problems that you might want to solve, and you can SDN controllers solve some of those, going in and just like hacking away at stuff, solve some of it. And this network service mesh gives us a really simple, easy to use abstraction to basically present those solutions to you. Ultimately, it does kind of require somebody, whoever built the network service, like we found this out when we were building ours, was we had to puzzle through all sorts of stupid networking stuff to actually get it to work. But then once it works once, turn it over to the community, and you don't have to then go and resolve that.
Yeah, in a way, like what you're saying is disintegrate what all the controller would do, like the functionalities, and then that's there in the community toolbox, right? You pull in whatever you need. Okay.
Mm-hmm.
Yeah.
Exactly. Yeah.
So a lot of the way I kind of think about it is when you look at SDN, and you look at even the roots of where SDN came from, right? It was how do we programmatically program literally a vSwitch? And there's lots of SDN controllers that do lots of cool things that will program all kinds of cool vSwitches and all kinds of cool things in your physical network. But at the end of the day, you still need something to get a virtual wire from your workload to that network service that your SDN controllers provided for you. Looks like we have another question? Or just...
Well, this community, NSM, is primarily about the management plane and control plane side of it. Would you mind taking a data plane question? Okay. Thank you. It's a brain trust out here as well asked, right? So there is quite a bit of data plane what DBDK started bringing into user plane, and VPP also uses that. But we see that kernel networking has also come a long way with XDP. There was Ericsson color on that today. So does the panel have commentary to provide in terms of what is weight? It's going to be a mixed bag that we know the answer, but commentary would be helpful.
Okay, there's the geek side of me who will say that eBPF is really cool. There's the operator side of me who will tell you that at 2 o'clock in the morning on Saturday night, and my NOC has a failure, and they don't know what's going on because it's an eBPF failure, compared to troubleshooting directed graphs into VPP. That's where I put my bet. That's really this. That's the only reason I won that bet.
Other answers?
I spent a couple of years into the user space networking, and I was completely convinced that the way that DPDK is going is, the right way to go. I still think that there is kind of part of the business for these type of solutions. I like what Daniel said. That's absolutely true. On the other end, the progress with whatever is happening with eBPF, with XDP, AF, packet, yes. So all these things, they're kind of bringing the kernel networking into another space, into another domain. I mean, I guess that's most of the people know this already. So one of the reasons, I don't know if you are aware, but one of the data planes, the forwarder planes that we prefer to call them, that we have, is also the so-called kernel forwarder, which is very, very basic. It has nothing to do with eBPFs and any advanced kernel networking. But I personally think that using the kernel makes you more portable across various environments. So imagine public clouds. It could be challenging integrating whatever. I mean, if you're not using the standard kernel primitives that are available out there. So we also have some advancements to come in this forwarder domain and the data plane. Our pictures are going to become slightly more complex to explain, but yeah, that's more or less. I don't know if this kind of adds to the answer for you, but I think that there's space for both. That's probably what I want to say.
So I have a perspective I'll bring in from enterprise and looking on the healthcare side. So one of the things that I've been working on is like how do I create multiple layers of defense and when I'm maintaining sensitive information. And so one of the things that I've been looking at was the possibility of using user space networking within that, because if I have a compromise, if there's a 0-day in my data plane, there's a big difference between a kernel 0-day versus user space 0-day. So I also think that there are some very interesting things that we'll find within the when we start to look at the security aspect of this, because we can lock it down a lot more, where that particular thing that's configuring your data plane for you. If you have to go and configure a user space process, it's like you don't have to give it net raw. You don't have to give it some cap sysadmin or some other similar scary thing. So I think that particular path is going to, like, even if you use kernel space mixed with some user space data plane, like I think that there's some very interesting opportunities for minimizing the overall scope of the security as well. And that's not to put down like the eBPF stuff. Like eBPF stuff is absolutely amazing and has implications well beyond networking. So one of the big enabling technologies behind containers, and just for background, I actually worked on containers. I had commit access to Docker before it was publicly released, so I know that history very well. And one of the things that eBPF landed in was seccomp. So you can pick and choose when you call seccomp. What it does is it removes system calls from your application. So historically, it would give you, your standard seccomp would give you read-write. a signal handling and exit once you called it, and everything else was removed. This allowed them to give you more capabilities and scope it down through eBPF, and eBPF was a enabling factor for helping us build those more secure containers. And so there's a really amazing work well beyond networking that eBPF is helping with. But I think mixing user space and driving down stuff towards user space is going to have some amazing security implications.
Yeah, one thing I do want to sort of really double click on is that network service mesh is not opinionated about your data plane, right? So the answer is you just heard a variety of opinions for a variety of good reasons as to considerations for why you might pick something for the data plane that acts as your NSM forwarder or the data plane that you might use for your network service. And at a very fundamental level, network service mesh is agnostic to those decisions. And the reason is because it doesn't matter how good any of our reasons are, and it doesn't matter how good any of the technologies are. 5 years from now, there will be new reasons and new technologies. And we don't want to be welded to any particular set of technologies today.
I'd also like to point out VMware implemented a kernel forwarding plane as well. So we do have a kernel-based data element there.
Yeah, thanks. One other thing that probably is worth mentioning here, I don't know how new are you to this domain with NSM. So essentially, with the forwarders, that's why I'm kind of pushing this word, and we figured out at some point that we want to call them forwarders. We want to make them dumb, if we can use this word here. Just like they should provide very, very simple point-to-point connectivity. And actually the real smartness of the data plane is essentially what we call network service. So that's more or less user space. I mean, containers.
More questions?
No more? Are we? Are there any questions from people up here who want to ask the audience, or?
I have questions to the fellow speakers here. So, so first again, thank you for presenting at this conference. It's something that I really appreciate for myself. So, how easy was for you to join our community? I mean, join is probably not the proper word here, but to adopt NSM for the solutions that you are building.
Took a while. I think it's quite tough because there is no documentation. You have to read the code actually to do it. But then I got good help from you to start with. Actually, when I wanted, you put the first bridge domain in. Mm-hmm. I was trying to follow the video when Ed and Frederick did this 1 year ago. But and this is also one problem because very quick I realized that the code base I checked out was like way newer than the one on the video you had. So I couldn't even like try to put code into the same lines.
I'm sorry.
And that's because the SDK came in probably just after your demo. So, yeah, it's not super easy, but I think when you got a bit of a hang of it, it's not that tricky anymore, I think. Because, I mean, the protocol is quite straightforward.
Yeah, I mean, I think that with every open source project, it's not an excuse, of course, but yeah. So in this particular example, instead of me trying to write proper documentation, I just wrote the code because that was easier for me. Engineers, you know.
Yeah, it was good.
This is the code.
Yeah.
Use it.
It's also easy for me to read code and documentation. So it's
Yeah, so I think from my perspective, it was also the documentation. It was very, very easy to get started, very easy to get started. But then once you wanted to do something a little more sophisticated, the documentation was challenging and you had to actually read the code. So one thing that, and one thing that I really like is the examples repo is a pretty good cycle of different things. But I think what might help is if you have one really, really like showcase example that you document the shit out of. Because I saw like the Istio community did that. They have one particular example, they document the shit out of it, anybody at any level can get started on that. I think that would be helpful. And then you can leave the other examples sort of to be the way they are and, let people really read the code and dig into it. But if you have one really showcase example, I think that would be helpful.
Yeah, I think that's a fantastic idea. And if anyone wants to help with that, we have.
No, I was.
We actually had a different experience. It was really easy for us, and it wasn't that the documentation wasn't there. There were some gaps in documentation, but whenever we ran into those docs or those gaps in documentation, we just messaged Ed immediately, and we were like, we're missing something here. And that's why it was easy for us, because Ed, as busy as it was, responded back within like 2 minutes every single time. Yeah, so.
I'm on Slack, guys.
Yeah. So that was our experience, is that, and I think somebody else mentioned that somebody else was helping them, so like they're really helpful. Yeah.
Well, how many people do we have working on it now, like for like most of their time? I think it's close to 10 people now, if you look at combine like Cisco and VMware and a few of the other companies. Like, I think that's around the number. Like, there's.
We've got the Slack community is really lovely. I mean, there are people there around the clock mostly. So.
Yeah, and so I'm quite serious though. Like, if you want to get into this community and want to help out, and there's like when you add in this feedback and mix it in with Zia's feedback as well, it's like it's a good opportunity for you to learn and to help the community out simultaneously, because like you get answers pretty fast. Like the community is incredibly responsive, and people don't care like what company you come from. It's like you just come in and people are helpful, and so.
And they don't care how stupid your questions are either.
Well, I haven't seen any stupid questions. If someone wants to submit one of those as well, I'd be happy to answer it nicely. But no, the community's been fantastic. It's like I actually think that's the biggest strength, and going back to what Ed mentioned before, it's like, if we were to suppose that our GitHub repo just suddenly had a massive corruption and on everyone's system simultaneously, like I'm confident that this community could build something even better. And so, I'm honored to be a part of it, and I think that as moving forward, like we're gonna solve some pretty amazing some amazing things. But these type of gaps definitely need to be resolved, and any help that people can give on this would absolutely help propel the community forward.
I'd like to add, it would be very useful if anyone who had troubles writes about them and what exactly was missing in the documentation, so we can see that and focus on the things that people were struggling with instead of just randomly trying to document.
Yeah, it's not so easy because I've been doing like probably 10 presentations for like people locally about what NSM is, and most of the time they look like question marks and say, I didn't understand the shit they say, But then one day, one guy that I work very closely with said, yeah, today I understood everything. Because it's so easy when you get this with the wires. Then people usually get it. But before that, they have a hard time to get it. Because they probably read more into it than what it is, I think. Yeah.
We actually got probably the nicest compliment ever at KubeCon North America last year after one of our presentations, when someone sort of came up when there was a whole crowd of people talking afterwards and said, well, the nice thing about NSM is it's ambitiously unambitious. Yeah. We're mostly just doing the V-wires, right? And you can bring whatever network service actually solves your problem.
Yeah. That's also the strength with the concept, I think.
Oh, absolutely.
Yeah.
I just realized I asked you to document what you were struggling with.
I tried.
Changing your tone a little bit, can I go to the usability part of it? Well, the way I see it is service mesh, STL, is potentially one use case where NSM can be used. Managing and configuring the STO service mesh itself is a piece of work. And then maybe I missed some of the morning sessions, and if you guys talked about it, please pardon me. But is there a way to get NSM in that workflow to streamline? If someone want to use these two together, then the configuration, deployment, and management would be easier.
So I don't know, we, right after lunch, we had a talk where we integrated. Were you present for that? Did you see that talk, or you missed that one?
Well, looks like I missed that one.
Yeah, so we had a talk integrating, showing Istio on top of NSM. And
Awesome.
the way we looked at it really was a little bit different than what you said, because we don't see NSM as being like a programmer of Istio or even necessarily a programmer of Envoy. I mean, there's a lot of control planes. SMI is trying to address that. Istio has a control plane. We see NSM more as trying to create the networking foundation that makes it very easy for Istio to run on top of. And if you know, we can talk outside or later this week, or you can check out our demo, but we show exactly how you could do that. And it's fairly straightforward. We didn't have to change Istio at all to accomplish what we needed to do.
Oh, awesome.
And just to add, though, I mean, your idea, I mean, the way you said that, of, you know, Istio kind of integrating with NSM more tightly, I guess. You could have, in fact, use information from the Istio API to kind of drive, again, what we presented in that you missed. But essentially, the vectors for how an application behaves through the control or the data flow through a set of microservices could be potentially used to model like in our case, we showed a multi-cloud deployment of NSM.
Federated microservices.
Yeah, and so it could, you know, if you had the wherewithal to create some feedback from that API or something that consumes that API information, or maybe the feedback of like the service graph that you can see from Istio monitoring, to get you your NSM level, like to basically essentially describe what things need to join a network service. You could do that. It's something that but it's kind of left outside of NSM, and maybe even outside of Istio. It's a thing that could be valuable, but it would be kind of use case specific, I think.
That's what I was getting to. People had to do twice right now.
Yeah.
And, two-step approach. And the way I see it for microservices management and deployment, Istio and Istio-based products, the adoption is quite a bit.
Yeah. Right.
And this can be a great use case for NSM to be creating that underlying L2, L3 substrate on multi-cloud as well as hybrid cloud type deployments.
Yeah, exactly.
Okay, so I think we're coming up to the end of our time. But before we finish, are there any short questions of any unanswered questions or lingering thoughts? Okay, with that, again, a round of applause for the speakers.